You know that feeling. You're sitting there, maybe you've got your AI assistant open on one screen, generating text, brainstorming ideas, and then right next to it, you've got your actual work. Your files, your database, your project management tool, your internal APIs, and you can see the potential. You
Yeah.
think, man, if the AI could just reach into that, if it could access those specific client notes in the CRM, or update that status in Jira, or pull that data point from the spreadsheet,
Right.
it could save me so much time. But then the reality hits. Getting the AI to talk to your systems, your data, feels like building a brand new custom-engineered bridge for every single little task.
Yeah, it's fragmented.
It's fragmented, it's manual, it's tedious.
Tedious is exactly the word a user used in one of the online discussions we looked at. It's often called the MXN problem in integration.
Oh, not cause then.
Yeah, you have M different AI applications or agents and N different tools or data sources you want them to interact with. And without a standard way to connect, well, if it feels like building M times N unique connections. You're figuring it out from scratch each time, as that user put it. It's just a massive bottleneck.
Absolutely. A huge barrier to really making AI a seamless part of your workflow. And that fragmented feeling. That's what we're here to talk about today.
Right.
We're taking a deep dive into something designed specifically to solve that problem. The Model Context Protocol, or MCP.
Yeah, and just to be super clear up front, because MCP pops up in a few places in the tech world.
Right, like certification.
Exactly. Maybe you've heard of a Microsoft certified professional or even managed cloud platforms. Things like that show up in some sources. But that's not what we're focusing on today. Not at all.
Right. This MCP, the Model Context Protocol, is a very specific thing. It's an open standard introduced by Anthropic, late 2024, relatively recently.
Yeah, pretty new. And its whole mission is to create a standardized, secure way for AI models like Claude and potentially others down the line to interact directly with external systems, things like your file system, your databases, your calendar, third-party APIs, you name it.
Okay, so our goal in this deep dive is to unpack exactly what this particular MCP is, how it tries to tackle that MXN headache, what it looks like under the hood, maybe the nuts and bolts.
Yeah, get into the mechanics a bit.
And most importantly, what it could mean for you. If you're someone who wants your AI tools to be more than just conversational interfaces, if you want them to be active participants, capable assistants integrated into your actual digital life, well, this protocol seems key.
It really does. And we've pulled insights from a really interesting Reddit discussion where people who are actually, getting their hands dirty with this are sharing their experiences, their frustrations.
The bad.
Exactly. And their aha moments, too. And we've also been digging into a detailed developer guide for the protocol itself. So that gives us both the kind of theoretical blueprint and the messy, exciting reality of people trying to make it work right now.
That's a great mix. Okay, let's start there. What is the fundamental shift MCP introduces? We talked about the problem. AI models stuck in isolation, lacking real-time context from your systems.
Right. Think about how most interactions work now. You might copy text from a document or a database.
Yep, done that a million times.
Paste it into the AI, ask a question, get an answer, then copy the answer back out and manually perform an action somewhere else.
Right, super manual.
That's because the AI doesn't inherently have the, let's say, eyes or hands to interact with those systems directly. It's just a brain in a box, basically. Receiving input, generating output.
Okay.
And giving it those eyes and hands used to require that significant custom coding effort we mentioned, building those bespoke bridges for every single link you wanted to make.
So MCP provides the standard way for the AI to get those eyes and hands. That's the idea.
Exactly. It standardizes the how of that interaction. Instead of building a unique custom bridge for every pairing of AI model and external tool, MCP defines a universal blueprint for the bridge.
A blueprint, okay.
And this dramatically simplifies that MXN problem we started with. It essentially turns it into an N plus M problem.
Okay, explain that N plus M a little more. I'm trying to picture it.
Think of it this way. You have MAI clients. These are different AI applications that are MCP aware, like the Claude desktop app, for instance.
Got it, the AI side.
Right. And you have N different tools or data sources you want to connect to your file system, your database, Slack, whatever. Your stuff. With MCP, you only need to build one MCP server for each of those N tools.
Ah, okay. One server per tool.
Right. And once that server exists, any of the M-compliant AI clients can potentially connect to it and use its capabilities.
Yeah.
The MCP protocol provides the standardized glue that allows any compliant client to talk to any compliant server.
Ah, so instead of M times N custom pieces of glue, you have N tool-specific pieces of glue, the servers that can connect to M standardized recipients, the clients.
You got it.
That really does sound like a much more scalable approach. Less building, more connecting.
It is. And the architecture reflects this. It uses a client-host server model.
Okay, break down those roles for us. Client, host, server.
Sure. The host is typically the AI application itself, or maybe something that manages the connection process. Think of it as the central hub where the AI lives.
Like the Claude app.
Yeah, potentially. The client is often embedded within or works closely with the host. It's the component that handles the actual establishment of the connection and routing messages to the correct server.
And the server. This is where the connection to my stuff happens. This is the important bit for me.
Yes, absolutely. The server is the piece you build or deploy that acts as the interface between the MCP protocol and your specific external system.
Okay.
This server is responsible for exposing the capabilities of that system to the AI in a standardized way. And these capabilities are exposed through 3 core primitives defined by the protocol. Tools.
Tools like actions.
Exactly. Executable functions or actions the AI can trigger, like create a GitHub issue or run a database query. Then there are resources.
Which would be data.
Pretty much. Represent data sources or pieces of information the AI can read from or write to, like a specific file or a database table. And finally, prompts.
Prompts. Like reusable instructions.
Yeah, essentially reusable templates or instructions that can be passed around. Tools, resources, prompts, those are the core building blocks the server exposes.
Okay, that makes sense. So the server translates the AI's standardized request using those tools or resources into an action on your specific tool or data source, and then translates the result back into a format the AI understands.
Precisely.
It's like giving the AI a universal remote control, but you still need a little adapter box, the server for each device you want it to control.
That's a great way to put it. Or, as one user in the Reddit discussion put it, it's like Sherlock Holmes.
Okay.
The AI, with brilliant reasoning, needing Watson. Watson is his external EQ organ, right?
Yeah.
Helping him interact with the world, search for information, manage his environment. The MCP server is Watson.
I love that analogy.
All right.
Sherlock can deduce anything, but he needs Watson to go check the records, interview the witness, find the specific street. He needs that real-world interaction layer.
Exactly.
The developer guide also uses the analogy of a breadboard. You can plug different components, the MCP servers, into Claude, the client host, easily.
Yeah, it really fosters that modularity, allowing you to connect different capabilities as needed, mix and match.
So how does this plugging in or talking actually happen technically? What's the language they use? Under the hood.
Right, the mechanics. The
Yeah.
protocol uses JSON-RPC 2.0 as its underlying communication format.
JSON-RPC 2.0. Okay, for those of us who aren't network protocol experts,
Yeah.
what does that mean in plain terms? Like, simply.
Simply put, it's a standard lightweight way for 2 computer systems to exchange messages over a network.
Okay.
Specifically for one system to request another system to execute a function or method and get a response back. The messages are formatted using JSON.
Which is pretty common.
Very common, a widely understood data format. Each request gets a unique ID, so the system receiving the response knows exactly which request it belongs to. It's just a structured way of saying, hey, server, run this tool with these parameters, and getting a structured, okay, I did it, and here's the result back.
Got it. So it's the standardized message format. How do the client and server actually send those messages back and forth? Do they have to be running side by side on my machine?
Not necessarily. The protocol supports different transport mechanisms. For local connections, say if you're running an MCP server on your laptop to give the Claude desktop app access to your local files.
Yeah, like my documents folder.
Right. They can communicate using stdio. That's standard input-output, basically sending messages back and forth over the same communication channels, typically used for a program's standard text output or input. It's very efficient for processes on the same machine.
Okay, so that's for local access. What about connecting to something remote, maybe a server running in the cloud or on my company network, a database somewhere else?
Right. That's where the Streamable HTTP transport comes in. This is the current standard for production and remote connections.
Streamable HTTP.
Yeah, it uses standard HTTP endpoints, the same kind of technology your web browser uses to talk to websites, but with extensions to make it streamable, allowing for potentially longer-lived connections and sending data or messages incrementally. It's built on familiar web standards, which makes it easier to integrate into existing infrastructure.
Okay. Now, giving an AI access to your files, databases, and tools, I mean, it sounds incredibly powerful,
Yeah.
but also potentially risky. Security has to be front and center here, right?
Absolutely critical. And the protocol specification takes this very seriously. Security is explicitly built into the standard. For authentication, proving that the AI client connecting is who it says it is, or acting on behalf of a legitimate user, it mandates modern standards like OAuth 2.1,
Okay.
including best practices like PKCE.
OAuth 2.1, PPKCE.
Okay.
Okay, more technical terms. How does that translate to practical security benefits for me, the user?
Well, OAuth 2.1 is a widely used standard for delegated authorization, letting one service use another service on your behalf without sharing your password.
Like login with Google, that kind of thing.
Yeah. Exactly like that, but often for API access between systems. And PKCE, or Proof Key for Code Exchange, is a crucial layer on top of that, especially important in mobile or desktop apps. It adds a security layer to prevent certain types of attacks where malicious software might try to intercept the authorization code. Essentially, it means the authentication process is happening using strong, industry-standard, secure methods to verify identity and grant permission. It's not just some homebrewed security.
Okay, so it's using best practices for authentication. That's good. What about my control over what the AI can actually do or see? I mean, I don't want it randomly reading my entire hard drive or deleting files without asking.
No, definitely not. And this is where user consent and control comes in, which is a core principle of MCP. The protocol requires explicit user permission before the AI can access specific data or execute particular tools.
Explicit permission, always.
That's the design goal. When an AI wants to use a capability exposed by an MCP server, the host application, like Claude Desktop, is designed to ask you, the user, for permission first. Can Claude access your Google Drive? Can Claude run this create issue tool?
Okay.
There's also emphasis on tool safety. Tool descriptions should be clear. You should understand what an action does before granting consent. And access controls, limiting the scope of what the AI can do, are supported through mechanisms like OAuth scopes, which allow for fine-grained permissions.
That's a huge relief.
Thanks.
It's capability, but with speed bumps and explicit sign-off from the user. It's not just throwing the doors wide open.
Precisely. It's about empowering the AI, yes, but keeping the user firmly in the driver's seat regarding permissions and actions. Control is key.
All right, so with this standardized, secure way of connecting, what can you actually do? What external systems are people connecting, and what are the real-world use cases emerging? The Reddit thread and the dev guide listed a bunch of interesting examples.
Yeah, this is where the potential really comes alive. Anthropic has released official sample servers for a wide range of common systems. File system, GitHub, GitLab, Google Drive.
Okay, the big ones.
Yeah, databases like PostgreSQL and Squite, Slack, a specialized memory server we should talk about, Puppeteer for browser automation.
Browser automation.
Yeah.
Wow.
Brave Search, Fetch for grabbing web content, Google Maps, Sentry for error monitoring. The list is quite extensive and it's growing. Community servers add even more.
Just hearing file system and Google Drive connected to an AI sparks a lot of ideas. Accessing my own documents seems like a huge one.
It is. Users are already experimenting with giving Claude access to local files or Google Drive. And it's not just passive reading. The protocol supports actions like writing, appending to files, or even changing permissions.
Really? Writing?
With user consent, of course. Always with consent. One user mentioned connecting their Obsidian Vault using the file system server.
Oh, interesting. Like a personal knowledge base.
Exactly. Imagine asking Claude to find notes on a specific topic across your vault, synthesize them, and even add a new summary note, all directly within Obsidian. No copy pasting.
That would be incredible for managing personal knowledge. And another user in the thread talked about giving Claude access to their development project files.
Yeah, I saw that.
And seeing Claude literally change, update everything as they chatted about code. They mentioned it replacing manual code copy-pasting.
No more copy-pasting code back and forth. That's a productivity game changer right there for developers.
Totally.
Being able to give the AI access to your code repository via a GitHub or local file system server means it can understand project architecture, help debug by inspecting actual files, and yes, even edit code files directly based on your instructions. It turns the AI into much more of an active coding partner.
Okay, that's files and code. What about structured data, like databases?
The sample servers include read-only access for databases like PostgreSQL and SQLite.
Read-only, mostly.
Primarily read-only in the official examples, for safety to start. This allows the AI to understand the database schema, the structure, and run simple queries to retrieve information. Users are looking at connecting this to internal systems like ERP or CRM for quick lookups, analyzing database structures, or getting help debugging SQL queries.
So instead of writing a complex SQL query myself, I could potentially ask Claude in natural language to get me the last 5 orders for customer X, and it can figure that out.
For read-only access and suitable queries, yes, that's the idea. The AI, via the MCP server, can interact with the database to understand its structure and execute queries based on your natural language request, returning the results. Saves you the step of manually writing and running the query.
Okay. And beyond files and databases, what about automating tasks across different apps? That sounds like where the real power could be.
This is where the agentic AI potential really starts to show. People are building servers to connect to their specific workflows.
Custom servers.
Right. Examples from the sources include creating GitHub issues automatically based on incoming emails.
Oh, nice. Managing invoices across different systems like Notion and bank accounts by analyzing your inbox, or building custom tools for specific third-party APIs. One user built a server for the NHL API to pull fantasy hockey stats on demand. Okay, that's pretty specific. It shows the flexibility. Accessing your calendar, getting weather updates. Basically, anything that has an API or can be controlled programmatically can potentially have an MCP server built for it.
And you mentioned browser automation using Puppeteer.
Yeah. Using the Puppeteer server, you could potentially have the AI interact with websites. Things like ordering food or filling out forms, provided the server is configured for it, and again, you grant permission for each action. Ordering food via AI. That definitely feels like it's pushing the boundaries of what we imagine an AI assistant can do today. Sort of science fiction becoming real.
It does, but it highlights the breadth of possibilities when the AI gains this capability to act in external systems. Another really interesting example is the memory server.
Memory, what does that do?
It's not just dumping chat history. It's designed for persistent note-taking or context management that the AI actively uses and adds to.
So it remembers things across chats.
Sort of, but more structured. It can act somewhat like RAG retrieval augmented generation, but focused on structured, decided context rather than just retrieving from a raw document dump. Users are connecting project folders via the file system server and then associating them with a memory server, so Claude can build a persistent understanding of different projects across conversations.
Whoa. So the AI can actually learn and maintain context about my ongoing work, building its own knowledge base about projects or clients that persist between sessions. That's huge for continuity.
Exactly. One user described this setup, allowing Claude to immediately know where to look at what stage the project is at just by mentioning the project name. No need to re-explain everything.
That ability to actively manage context, access live data, and execute actions in your real systems. It fundamentally changes the interaction model, doesn't it?
Completely. It moves from just asking questions and getting text to having a teammate who understands your entire tech stack, as one user perfectly described it.
A teammate, yeah. Another felt like it gave them a superpower.
That feeling of empowerment really comes through in the user comments.
Okay, so let's zoom out a bit. If we have to sum up the why does this matter, what are the key benefits MCP brings to the table? Why should people care?
Well, the single biggest one is tackling that integration complexity we started with. It transforms the custom MXN nightmare into a standardized N+M approach. It makes integration possible and scalable where it maybe wasn't before for many users and businesses.
And that directly unlocks the potential for truly agentic AI.
Exactly.
Allowing AI to go beyond just generating text and actually do things, take action in your external system.
Precisely. And this streamlines workflows. It cuts out those manual steps like copy-pasting data between applications that we all dread.
Definitely a developer's dream. And frankly, anyone who spends time moving data around between windows.
Yeah. It also enables deeper integration. The AI can maintain context across sessions, like with that memory server, and access diverse information sources simultaneously through different servers. This leads to richer interactions and more informed actions.
Right.
And ultimately, this boosts productivity for individual users getting tasks done faster and for developers building and deploying these integrations more quickly.
And for businesses adopting this kind of technology, what's the potential impact there?
The sources point to significant potential business impacts: faster decision-making by accessing real-time data, reduced administrative burden through automation.
Less grunt work.
Right. Improved customer satisfaction with more capable AI assistants, and optimized operations across various departments: finance, healthcare, customer service, software development, manufacturing. Being able to connect AI to things like patient records, customer orders, code bases, or factory sensors via a standard protocol opens up a lot of possibilities for efficiency and innovation.
It really does paint a picture of AI becoming a much more active, integrated partner in our work. But okay, let's be realistic. It sounds powerful, but it can't be a magic fix for everything, right? What are the challenges and realities of implementing and using MCP? The downsides.
Absolutely not a magic wand. While the protocol is standardized, building and maintaining the specific MCP servers that connect to your unique systems still requires development effort.
Right, someone still have to build that adapter box.
Exactly. The developer guide is clear. Someone needs to write and maintain that server code. It doesn't just appear.
And the data itself is still crucial. Garbage in, garbage out still applies.
Hugely important. The sources stress that even with perfect MCP integration, if the underlying data that the server exposes is unreliable, inconsistent, or poorly managed, well, the AI project is still likely to fail or produce incorrect results. Data quality and governance remain paramount. You can't automate bad data.
What about managing all these connected pieces, especially in a larger organization? Seems like it could get complicated.
It definitely introduces operational complexity, particularly at scale. Deploying, monitoring, and managing potentially dozens or even hundreds of different MCP servers, along with the AI models and data infrastructure. That requires robust MLOps, machine learning operations, practices.
I'm bulkhead.
It adds components to your overall system that need careful management, monitoring, and scaling. It's not trivial.
And running all this needs resources. Compute power, money.
Yes, there's an infrastructure cost. Both the AI models and potentially the MCP servers themselves require adequate compute resources, whether you're running them on premises or in the cloud. These costs need to be factored in and managed efficiently.
And the security picture, it extends beyond just the protocol handshake, doesn't it? It's the whole chain.
This is a critical point raised in the sources. Securing an MCP-enabled system means securing every link in the chain: the AI application itself, the MCP client implementation, the MCP server, the specific tool or API the server connects to, and the original data source.
Wow. Okay, lots of points to secure.
Yeah. Managing security across this potentially distributed landscape requires careful planning, centralized management where possible, and diligent application of best practices at every layer. And again, rigorous enforcement of user consent for actions and data access is absolutely essential.
So the standard makes the connection easier, but you still have to build the connector, manage the data quality, handle the operations, and secure the entire distributed environment.
Exactly. And debugging can also add complexity when you have multiple components interacting. Though tools like the MCP inspector, which helps visualize the protocol messages flowing between client and server, are being developed to help with that.
Good to know there are tools emerging.
Yeah. And as one user noted, while MCP is powerful, it might not be the absolute best tool for every single job, for instance. Analyzing massive document libraries might still be better suited for dedicated RG pipelines designed specifically for that task.
Right tool for the job.
Precisely. And yes, it does require some technical setup, installing servers, configuring connections, managing those config files. It's not zero effort.
Okay, so it's powerful, but requires careful implementation and management. Where is this all headed? What's the ecosystem like? And what does the future hold for MCP? Is it catching on?
Well, the ecosystem seems to be growing quite rapidly. Anthropic has released official SDKs in major languages like Python, TypeScript, Java, C#, Ruby, Swift.
Covering bases.
Yeah, making it easier for developers to build those servers. And the community has been incredibly active since its launch. The sources mentioned something like building over 1,000 different servers connecting to various tools in just a few months.
1,000. Wow, that's fast uptake.
It really is. Development tools like that MCP inspector we mentioned, community-led projects like MCP tools for managing servers, and even an MCP registry for discovering available servers are starting to emerge.
That kind of community momentum is a very strong signal for a new standard, isn't it?
It really is. And enterprise adoption is starting to pick up too, with companies like Block, Apollo, Replit, and Sourcegraph beginning to integrate MCP capabilities into their platforms and workflows.
Okay, so it's moving beyond just individual experimenters. What about other major players in the AI space, beyond just Anthropic? Is this just a Claude thing, or does it have broader industry potential?
This is where it gets really interesting and hints at MCP potentially becoming a widely adopted standard, not just an Anthropic one.
Oh,
The sources indicate that other major AI players are planning to integrate support. Google DeepMind has announced plans to incorporate MCP support into upcoming Gemini models.
Gemini 2?
Yeah, potentially as early as April 2025, according to the source. And Microsoft Copilot Studio is also planning MCP integration for enterprise scenarios.
Wow, okay, so this isn't just an Anthropic-specific thing. If Google and Microsoft are getting involved, it seems poised to become a cross-model standard for external tool use. That's big.
That appears to be the direction the industry momentum is pushing. The protocol and the ecosystem are expected to continue evolving, looking at optimizations like AI-aware server design, exploring different deployment architectures like serverless.
Making it easier to run those servers.
Yeah, exactly. And even potential integration with other emerging protocols, like Google's A2A protocol, which aims to standardize communication between AI agents, so inter-agent communication as well.
It really sounds like we're on the cusp of AI moving from being an isolated brain in a box to becoming a truly connected, capable assistant that can interact with our entire digital environment.
Definitely. MCP seems like a really foundational piece that enables that next leap in AI capability and integration, a key building block.
So to sum it all up then, the Model Context Protocol, MCP, is a significant open standard, started by Anthropic but gaining wider traction. Its core purpose is to standardize how AI models can securely access and act on your external tools and data,
Right.
transforming that complex problem of building countless custom integrations into a more manageable, scalable N+M approach.
It opens up exciting new possibilities for automation, workflow improvement, and deeper interaction with your digital world, allowing AI to move beyond just generating text to becoming a real action-oriented assistant.
However, it's not a plug-and-play solution for everything. It requires effort to build and manage the necessary server infrastructure,
Yep, the servers are key.
and demands careful attention to data quality and security across all components of the system. But understanding MCP helps you see how AI is evolving, moving towards becoming a truly integrated teammate that can understand and work within your existing tech stack.
And this potential raises an important question for you, our listener, as you think about your own work or personal life. Considering the possibility of an AI assistant securely accessing and acting on your data and tools via something like MCP, what is one specific task or workflow, personal or professional, that you would most want to see automated or enhanced by an AI with this kind of integrated capability? What's the first thing you'd connect it to?